So now we are going to be looking at how to graph parabolas in standard form. So we learned a lot about how to graph the quadratic equation, or what features there are in the graph of a quadratic equation. We've looked at the direction they're going to open using the a value. We've looked at how to find their axis of symmetry using opposite of b over 2a. We've learned how to find their vertex by plugging in our axis of symmetry value, and we've learned about where their y-intercept should lie. So all we really have left to do now is take all of that information and plot it on a graph. So that's what we're going to do. So first thing we'll be looking at is, does the parabola open up or down? Just to give us a general idea of what the graph is going to do. So then we're going to find our axis of symmetry. We'll do our opposite of b over 2a. And so then we'll find the y value of the vertex and plot that point. We're going to make a table of values with 5 points, with the center point being our vertex. So so if the vertex was 0, we want to pick 2 points before the vertex and 2 points after the vertex. So if this was 0, then we would pick -1, -2, and then we would pick +1, +2. Or if the vertex x value was at 5, then we would pick 4, 3, and then we would pick 6, 7, so that it's counting in numerical order. We substitute all of those x values into the equation one at a time and find the y value. We should see some symmetrical values coming out here so that we can see that that graph is really symmetrical around the axis of symmetry. And then we're going to plot all 5 points on the graph. So let's take a look here. I've got some delta math problems. We have the equation y equals x squared plus 6x plus 5. So our a is going to be 1, our b is going to be 6, and our c is going to be 5. So first thing we'll do is x equals the opposite of b. So I'm going to do -6 over 2 times a being 1. So then that's going to give me -6 over 2. And so that would reduce to just x being equal to -3. Okay. So then what I'm going to do is I'm going to basically make a table of values. So I'm going to pick 1, 2, 3, 4, 5. So my center, so I'm just going to kind of make this look a little nicer. Boom, boom, boom. So my center point is going to be that -3. So then I'm going to pick 2 more points before that and 2 points after that. So I could say -3, -4, -5, and I could say -2, -1. So do you notice how it's counting 1, 2, 3, 4, 5, or -1, -2, -3, -4, -5. So then the next thing that I'm going to have to do is I'm going to grab my handy dandy calculator, and I'm going to be plugging these numbers into the equation. So maybe my computer has been moving awfully slow. Let's see here. Where's my handy dandy calculator? There it is. Okie dokie. Now I just gotta wait. Maybe. I think I clicked on it. There we go. Okay. So if I plug these numbers in hindsight, I should have had this ready to go. So if I plug these numbers in, I have x squared plus 6x plus 5. So I'm just going to write that over here. Maybe. Nope, it won't let me. X squared plus 6x plus 5. X squared plus 6x plus 5. That's a 5. We're going to pretend like that's a 5. Let's see here. There. Okay. So, and I have, let's start with our -1. So I'm going to put in parentheses. My calculator, I have to put the negative after the number, but that's okay. So -1, and I'm going to square it, plus 6 times -1 plus 5. So that gives me an answer of 5. Oh, I'm sorry, plus 5. That gives me an answer of 0. So, yeah, because that would be 1 times plus -6 plus 5. Yeah, that would give me an answer of 0. So there's my first point. I get a 0 here. And then we're just going to kind of keep going. So we just plug them in. So clear. I'm going to do 2, I'm going to make it negative, and I'm going to square it, plus 6 times negative 2 plus 5. And I hit equals, and I get negative 3. So negative 3. Then I'm going to plug in my negative 3. So I'm going to do parentheses, negative 3 squared, plus 6 times negative 3 plus 5. And I get negative 4. And we just keep on going. So now I'm going to do parentheses. I'm going to do negative 4 squared plus 6 times negative 4 plus 5. And I get negative 3. And that should be my sign that I've got things going in the right direction, because now I can start seeing that there's some symmetrical properties to this graph. So then one more, let's do this. So I'm going to do my negative 5. I'm going to put that in the parentheses and square it. Negative 5 squared is 25 plus 6 times negative 5 plus 5. And I get, lo and behold, I get 0. Oops, 0. That's supposed to be 0 right there. So now that I've got all of those, I'm going to just kind of take this and plot them on my graph. So I want to plot the vertex, which was negative 3, negative 4. And then I've got to plot the roots and the vertex, so those specific points. So I had negative 2, negative 3, and I had negative 1, 0, and then I also had negative 4, negative 3, and negative 5, 0. And once we get all 5 points plotted, because they do want you to plot 5 points, then your parabola will kind of connect itself, which is nice. So, and you can see the roots are the points that cross the x-axis. And we click submit, and yes, and boom, we're good to go. Okay, it even shows you a table of values and shows plugging those numbers in. It goes beyond just 5 points, but that way you can kind of see, check your numbers and see if you do get it wrong. You can check your numbers and compare them to the graph and see how you did. So I hope that that helps. I'm going to click new problem here just to see really quickly if we could come up with another graph here. So here we have one that's going to be negative. It's got a negative a value, so that means this graph is going to open down. So what I'm going to do, I'm not going to type it in the calculator on the screen just because it takes me a little bit to type that in. But I'm going to show you the same idea. So just so we can do that really quickly. So I'm going to do opposite of b. B is 8 in this problem over 2 times my a value, which is negative 1. So that's going to give me negative 8 over negative 2, which a negative over a negative will make a positive. So I know that my axis of symmetry is 4. And so then I need to plug these numbers in. So I'm going to make a quick table of values with 1, 2, 3, 4, 5, with 4 being my central point because that's the axis of symmetry. And then I would pick points on either side. So I could go 3, 2, and then I could go 5, 6. Okay, so then I would plug those numbers into my equation. And so then if I plugged in 2, so I'd have negative and then parentheses 2 squared, and I'm just going to type this into my calculator that I have in front of me. Negative 2 squared plus 8 times 2 minus 12. So that gives me, look at that right there, I get 0. And so then I'm going to just kind of go back through and plug in the 3, and that gives me 3. And if I plug in the 4, don't know if you can hear me typing this all into my calculator. There's my 4. And then we should see this reflection around the vertex. So I should see when I plug in 5, I should see that I get 3. So if I did negative and then 5 squared, that would be 25, but it'd be negative. So negative 25 plus 8 times 5 is 40, minus 12, and I should get 3. And I sure enough do. And then if I was to plug in one more time and plug in my 6, I should get 0 because this graph should be symmetrical. And I do. So there we go. There's my points. And I can plot these. So I had 2, 0 was a point, 3, 3 was a point, 4, 4 was a point, 5, 3 was a point, and 6, 0 was a point. And we said that this graph was going to open upside down, and we can see that yes, in fact, it does. So just so you have a couple of quick examples of how to plug those in. There again, you can see their table of values referring back to how they got all those numbers to work out. And we can see that our graph matches their graph. Okay, so hopefully that's enough. And of course, if you have more questions, if you're not sure, feel free to contact me and I can help you out.